So section 6.4, it's about basic matrix operations. So first we are going to start from the size of the matrix. So the size always represents the rows by columns. So you have to write the number of rows first and then write the number of columns. So I have this matrix. So I have two rows. So this is row 1, I'm showing you. So I have two rows here, row 1, row 2 by, and how many columns we have? 1, 2, and 3. So the number of columns are 3. So the size of the matrix is going to be 2 by 3. So the size is 2 by 3. 2 rows and 3 columns. And number 2, it says perform the integrated operation. That means we have to subtract two matrices. So when you're subtracting or adding, we have to have the same size. Otherwise, we cannot add or subtract. So this problem is subtraction. So let's first mention the rows, the size of the matrix. The first matrix is 3 by 2. There are 3 rows and 3 columns. And the second matrix is also 3 by 2. That means we have the same sizes, so we can subtract the matrices. To subtract matrices, we have to subtract the corresponding element. So we take the first element, the first row first here, and then first row, first element. So, and whatever the operation, that is subtraction. So -1 minus 2. And then you take the second element in the first row, second element, which is going to be 5, 1. And then go to the second row, so 0, then -7. And then the second row, second element is 4, -4. And then 8, -3. And then -4, -2. So now when you subtract, -1 minus 2 is going to be -3. 5 minus 1 is 4. Then -7. 4 minus 4 is 0. 8 minus 3 is 5. -4 minus 2 is -6. So this is our resultant, the answer for the subtraction. And if you notice this one, the answer matrix is also going to be a 3 by 2 matrix. And the third example, we have here is again subtraction, -1, 9, 3, and then 4 and 3. So let's first check the size of the matrix. So I have 1 row here and 3 columns. So it's 1 by 3. And there is 1 row here, but there are only 2 columns. So we cannot add them because they are not the same size. So the subtraction is not possible. So the answer is not, you can't subtract this matrices. Next, we are going to show you example for addition. So we have this addition symbol here. So make sure you got that one. So now we are going to add these two matrices. So let's first check the size of the matrix. So we have 2 rows and 2 columns here, and same thing here. So the sizes are the same. That means we can add these two matrices. So what we are going to do, we are going to add the corresponding elements in the row, each row. So first row, first element, first row, second element, and then second row, first element, then second row, second element. So you have to add, that's why the sizes have to be the same. And then so -1, 3, 4, and 2. And it's the same size, 2 by 2. Number 5, we are given 2 matrices. So we are given, let A is 1 matrix. It's a 2 by 2 matrix. And B is another 2 by 2 matrix. Now we have to find 4 times A plus B. So we're going to learn about the scalar multiplication. What that means, let's first find 4A. 4 times A, that is equal to 4 times the matrix A. What that means is you're going to multiply this 4 with each element here. So that is going to be 4 times 3 and 4 times 3, 4 times 2, 4 times 4. So that's what the scalar, the number here, it goes to all the number elements inside the matrix. So we get 12, 12, 8, and 16. So this is just 4A. Okay. Again, this is a 2 by 2 matrix. Now we have to find 4A plus B. So from the previous step, 4A is 12, 12, 8, 16. Now add B with this one. So B is the matrix 0, 4, -1, 6. So which is going to be 12 plus 0, 12 plus 4, 8 plus -1, 16 plus 6. So the answer is 12, 16, 7, and 22. Okay, so the next one is it says there's a word problem here. You just have to write a matrix to display the information. So please check the handout. It says a company makes 3 types of cable. So cable A requires, so let me first make it easier for you. So cable A requires, there are black, white, and red wires. So A requires 3 black, 3 white, and 2 red. And the company B requires 1 black, 2 white, and 1 red. And the company C requires 2, 1, 2. So basically we have to make a 3 by 3 matrix showing the wire requirements. So which is this one? 3, 3, 2, 1, 2, 1, 2, 1, 2. So it says assign the cable types to the rows and write the types to and the wire types to the columns. So that's what we did. Okay. Number 7, solve the problem. Bonds and Able sell life, health, and auto insurance. Sales for May and June are given in the matrices. So there are 2 for the 2 months, May and June. So for the month May, it's given. So it's going to be, so let's put, the first one is the life, health, and the auto insurance, which is 20,000 15,000 and 5,000. So this is month of May, and this is for first person. And the second person is March. And for the month June, same thing. Life insurance is 70,000 and 0 and 30,000 for Able, and 40,000, 20,000 and 32,000 for bonds. So we have to find the matrix that would give total sales for months of May and June. That means it's basically a simple one, M plus J. You have to add these two. So add the corresponding elements. So 20 plus 70 is 90. 15 plus 0 is just 15,000. 5 plus 30 is 35,000. And the second row is 70, 20, and 49,000. So this is the answer for this simple word problem. In problem number 8, we are going to learn how to multiply matrices here. So multiplication is a little bit different from, it's not as easy as adding or subtracting. It's not the direct multiplication. So I'm going to show you how to multiply matrices. We can use calculator as well. So I like to teach both manually and by calculator. To learn how to use your calculator, you can use, you can check the videos I posted in Canvas. So in order to do the multiplication, there is a rule. The first rule is, the rule is when you find the sizes of the matrix. So in this one, this column in the first matrix should be equal to the row in the number of columns in first matrix should be equal to the number of columns in the second matrix. That is one we can multiply. Otherwise, the multiplication is not defined. Here both are true, so multiplication exists, or we can find the multiplication of this matrix. So let's see how to multiply them. So it's AB equals, let me first write the matrix again. And I'm going to show you how to multiply matrices here. So in order to multiply this, you have to first multiply. You have to take the row here and the column in the second matrix. So you multiply 0 times -2 plus -3 times -1. So you multiply these two and these two. Okay, that's how it goes. And then you take the first row and multiply with the second column, which is 0 times 0, and you have to add them, -3 times 1. And then go to the second row, and then you multiply with first column, so which is 5 times -2 plus 3 times -1. And then take the second row and multiply with second column, which is 5 times 0 plus 3 times 1. So this is how we multiply. So it's going to be 0 plus 3, 0 minus 3. So -10, -3, 0 plus. Oh, sorry, here, I put the wrong number here. It's -1. 5 times -1 here. So I get -5 plus, wait, I'm sorry, 5 times, oh, 5 times, I put the right one, I'm sorry. I don't know why I keep changing. 5 times 0 is correct. And 3 times 1, so it's going to be 3. 3 times 1. So it's going to be 3, -3, -13, and 5. I mean, sorry, 3. I'm messing up with this number here. Sorry about that. Okay. Okay. Next, number 9. So we have to find again matrix multiplication. So we're given the first matrix 0, 4, -3. So every time you're adding, subtracting, multiplicating, you have to make sure the rule, the first rule, the sizes. So here I have 2 rows and 3 columns, and I have 2 rows and 2 columns. The condition for multiplication, the columns in the first matrix should be equal to the rows in the second matrix, but these are not equal. So that means the multiplication is not defined, or it's not possible. Okay. Next, number 10. We have determined whether the two matrices are inverses of each other. So in order to do that, I'll show you what the rule is. You can read the book as well. So the rules are, when you multiply two matrices, you have to have the identity matrix. The identity matrix means the 1 0 0 1. This is the identity matrix for 2 by 2 matrix. So this is the 2 by 2 identity matrix. So what that means, you have these numbers are called diagonal elements. So the diagonal elements have to be 1, and the rest of the numbers should be 0. If you get this one when you multiply, then these two matrices are inverses of each other. So let's check if they multiply to identity matrix. So I'm going to multiply the given matrices here. Again, you have to check the rules and the size. And the size is, here it's 2 by 2, 2 by 2. These two are equal. So the multiplication is defined. So let's multiply now. So you have to take the first row and multiply with first column. So you take this and you multiply. So it's going to be 5 times 2 plus 3 times -3. And then you take the first row and multiply with the second column. 5 times -3 plus 3 times 5. So we are done with the first row. Then take the second row. Take the second row and you have to multiply with first and the second column. So it's going to be 3 times 2 plus 2 times -3. So if you notice, these numbers are the same here because we are using the same numbers. 3 times -3 plus 2 times 5. So what do I get? So 10 minus 9 10 minus 9 here, and negative 15 plus 15, 6 minus 6, and negative 9 plus 10. So what I'm getting here, 1, 0, 0, 1. So that is the identity matrix we got. So the answer is yes, they are inverses of each other. So the next problem is going to be a little longer because we have to find the actual inverse of a matrix. So what that means, it's going to be a long process. So we are given a simple 2 by 2 matrix. This is the smallest matrix you can think of. Then we have 3 by 3, 4 by 4. But for finding the inverse also, you can use your calculator. But I'm teaching this one by hand. So what we are going to do is you have to write the augmented matrix with the identity matrix. So you have to write the given matrix and then write 1, 0, 0, 1, which is the identity matrix. So basically what we are trying to do is we have to convert this given matrix, this original matrix, into 1, 0, 0, 1. And whatever the answer you're getting next to it, it's going to be the inverse. Okay. So first we have to convert this. I have to make this one into 1 by doing row operations. What we have learned earlier, the row operations is we can do only division here or multiplying by non-constant 0. So what I'm going to do here is for row 1, I'm going to do this row operation. 1/3 times row 1, and that goes to R1. So I'm dividing everything by 3. So it's going to be 1/2, 0, 0 over 3 is 0. And then we get, this is our first row operation. Now I have to make this negative 5 into 0. How do I make negative 5, 0? We can multiply the first row by positive 5 and then add with 5 R1 plus R2. That goes to R2. So when you multiply row 1 by 1 times 5 is 5, minus 5 is going to be 0. And multiply 2 times 5 here, it's 10. 10 plus 6 is going to be 16. And the row 1 doesn't change. And you multiply this by 5. 1/3 times 5/3 plus 0 is going to be 5/3. And then 0 times 5 is 5 plus 1 is going to be just 1. Okay. Next, we have to convert this one, the 16 into 1. That means you have to divide by 16. Okay, so it's going to be it's going to look a little ugly. So it's going to be 1 over 16. You divide row 3 by 1 over 16. 0 by 16 is 0. 16 by 16 is 1. 5 over 3rd, 16 is 5 over 48. And then 1 over 16. The last one we are going to do is we have to make this one into 0, the 2 into 0. So that we can do by doing 2 R2 minus R1. So the last row doesn't change anything. So the first row is going to be 2 R2 minus R1. We can do that. So it's going to be 1, 0. And then when you do the 5, you can use your calculator to do the calculation. So I got this one. So the inverse of the given matrix is this whole matrix. This is our answer, which is 1/8, negative 1/8, 5/48, 1/60. So this is the answer for this question. I know if it's a 3x3 matrix, it's going to look even really bad. But you can solve this very straight, simple, and easy using your calculator. And you can look at the videos I posted in Canvas. And number 12, and this is going to be a word problem. So 3 different high schools plan to order the same 3 textbooks. School A plans to order 20 of book 100 of book 2, 80 of book 3. So let's write first the matrix. So I have school A orders of book 1, book 2, book 3. So it's going to be 20. Okay, so A, B, okay, you can write, let me put it in the other way. Sorry, so I have book 1, 2, 3, A, B, and C. So we have A, B, and C. So book 1 is 20, book 2 is 100, book 3 is 80, and then B is 40, 40, and 80, right? And then C is 70, then 40, and 10. So this is the matrix. And the cost of the book 1 is $15 per copy. The cost of the book 2 is 20 per copy, and the cost of book 3 is 25. What matrix product displays the cost to each school of mine? So we have to make sure we write the correct matrix format. So the cost is going to be 15, 20, 25. So it's a column matrix. There is only one column here. So that's why it's called the column matrix. So now we have to display the 2 matrices which must be multiplied. So what this means, there is only 1 row. So 3 columns here, and this is a 3 rows and 3 columns. So I have to write this column matrix first. So that's when we can multiply the cost with the number of books. So it is supposed to be, if I put the other way, then we cannot multiply the matrices. So this is the matrix multiplication. And when we multiply, so it's going to be 15 times 20 plus 20 times 100. Then 15 times 40. Sorry, 15 times 20. So it's going to be, let me write it a little, I need more space. 15 times 20 plus 20 times 100 plus 25 times 80. And then 15 times 40 plus 20 times 40 plus 25 times 80. And it's going to be a column matrix again. And the third element is going to be 25 times 7, sorry. Okay, I need space here, but it's okay. So it's going to be 15 times 70 plus 20 times 40 plus 25 times 10. So it is a column matrix again. So it's going to be 300 plus 2000 then 2. 600 plus 800 plus 2000, and then here 1 plus 800 plus 250. So we get 4,300 and then 3,400 and 2,100. So for school A, it costs $4,300, and school B, it's going to be 3,400, and then for school C, it's going to be 2,100. So this is for school A, B, and C. Okay, so number 13, we are going to find x from the given problem. We are solving the equation. So we are given A equals a matrix of 3 by 3 matrix, and we have B is another matrix. It's a row matrix. There is only sorry, it's a column matrix. I think it's sorry, I said the wrong one in the previous problem. It's a row matrix. When there is only one row, it's called a row matrix. When there is only one column, it's called a column matrix. So we have a B is a column matrix. Now we have to find x. Ax equal to B, then find x. So here x is going to be A inverse times B. So if you use the calculator, I would encourage use, because we can use the calculator here, so we don't have to spend too much time in finding the inverse. We can find the inverse of A. You can pretty much do everything with your calculator: multiplication, inverse, addition, subtraction, everything. So now multiply A inverse times B times B is 4, 10, 11. Again, use your calculator here as well. So we get 2, 6, negative 9. And the last one, same thing, solve the system using the inverse of coefficient matrix. So the matrix is given. First, we are given the systems of equations here. So the matrix is matrix A is 1, 1, 1, 1, negative 1, 3, 4, 1, 1. This is matrix A. And B is negative 3, negative 21. B is a column matrix. And we can take the X as X, Y, and Z. So first using the calculator, find A inverse. And then multiply with B. A inverse is so this is what we get A inverse. So therefore, now find X is going to be A inverse times B. And again, use your calculator to multiply this matrices. times -3, -21, -9. So we can get the matrix X. This can be a column or a row matrix, doesn't matter. But here we get a row matrix value because this is 3 by 3 and this is a 3 by 1. So you get 3 by 1 matrix. Or you can write this one as -2, 4, -5. It doesn't matter.